Okay, I think it started. So, hi guys, welcome to High Entropy, and very good morning, very good night to all of you. I don't know if we say give good night. Okay, so if anyone is gonna watch, so let me know. Uh, first of all, okay, so it's day 12 of AI learning, and I have started from yesterday. Like I have started learning Langchain. So it's basically, if I have to summarize in simpler terms, it's a framework to develop agents or agentic workflow. And yesterday, what has been covered in the video. So he covered the first what is Langchain, before that what is agentic AI, and what is agent, and how these are correlated, and what is the purpose, and how Langchain fits into this technology. Okay, so and he also explained like how it is more inclined with, or it's very similar to the data engineering activities, or Langchain is similar to you can think of like a airflow or something. I won't say it's similar to the similar in the terms of analogy, not like what we are doing there, what we are doing here. Okay, so why don't I summarize it first? Okay, so I have target of clock, like I know it's a little late, so I'm targeting like a till 5 o'clock. I will finish this stream, and I will read for 1 hour, but before that, not resume, cancel. Okay, so let me summarize it, what I learned so far. So because that is very important, if you are learning something, also I have to perform hands-on first, then I will jump into the next video. I will target 30 minutes. If I will watch video, then also it's good, like 30 minutes. I mean, if I'll watch at 1.75, then maybe what will be the time? 30 and half, 30 45 minutes of video I will cover. So maybe I need to watch for 45 minutes to cover what will be the I don't know, and so you can calculate it. My math is good, but it's not that good. Okay, so I will use calculator better than the. Okay, so what is the like a agents? First, we have to discuss agent, then we will get to know agent again. So agents are more. It's like a wrapper around the LLM. I will have to summarize it in simpler terms. Not wrapper, but it's like they are specialized to perform a particular task. So how they are helping? They are asking it to be done by LLM, and they are providing it a set of things, and then it is working around with the agent. So agent is like a person who is sitting and who is telling like let me ask. So instead of you directly interacting with the, you can say, LLM model, you specialized, you have particular task that you wanted to complete, and there is sitting agent, or you can say receptionist, and who will take care, like, okay, for example, if I will tell you in simpler terms, if you go to any hospital, and if they are senior doctors, there will be one person sitting in front of the at the gate of the doctors, like in front of doctor's cabin, and he will take care, like, okay, this is your number and now you have to go. What I observed in India especially, even if you have booked appointment, then also there will be, like, when I see in big hospitals, so agent is the person who will take care of, like, okay, who will go, who will not go. So it's a not similar, you can say, but it's almost in the similar way. Like, suppose you wanted to resolve the tickets, so what you will say, like, LLM will take care and agent will do some stuff, and then it will hand over to LLM if it is required, and accordingly it will respond to you back. So it's specialized to perform a specific task. For example, if you ask ChatGPT or any agent Claude, then what they do, they call LLM behind the scene. You don't interact directly with LLM, you interact with chat agent, and you can upload the files, you can do the things, and it work around it, and it generates it asks to LLM, okay, do this, and then accordingly it gets the output, and accordingly it would do that thing, further processing. So you got the agent. Now you have multiple agents. For example, you wanted to perform a goal, you wanted to achieve a goal. Let's say you wanted to resolve the customer queries. Now it could be related to sales, it could be related to technical team, or it could be related to, let's take example of Geo. So Geo, like when you call to their toll free number, or from your registered number, then what they will do? So someone will, like the main, you can say sales team, not sales team but customer queries team, you can say, what do we say, front facing team will attend your call, and maybe they will receive your call, and accordingly they will respond. If they need uh, it to be transferred to the technical team, then they will transfer to technical team. If you have issues with the sales related queries or billing related issues, then they will transfer to billing team, or so on further teams. So that's here you will see the coordination between different teams is happening, and they are specialized in their tasks. So it's like here you are building a, you are wanted to perform a goal, you have developed a business, now you wanted to perform different tasks over here. So you deployed different agents, and they all doing the things, and then they are performing particular goal, like growth of a particular business unit. Okay, so this is how. So now where Langchain fits into this environment. So if you notice now, the thing is like, okay, so he took the example of simple. Okay, so now there are different LLM models, and if you see, each has different terminologies, like how to call their APIs and all. Maybe they have different parameters, set of function, when you calling it using API, they have set of parameters and all. And now the thing is like, you have to remember everything. So Langchain helps you. So this is one use case I'm telling you. So Langchain wraps everything, and it makes unified system for you, so that you can call any LLM model with the similar structure, and it will be easy for you to do that. So that's how it works. It is front facing for you, and it will take behind the heavy lifting, and you will give the smooth framework it provides. Not only for this, it also provides framework how to build agentic AI. Okay, and agentic AI, I told you, like it's nothing but just set of agents that working in collaboration or workflows you are creating. Like one agent will call to this, and decision making and all. So the way there, Langchain helps you to build the things properly and in a proper structured way. Otherwise, you have to build everything from scratch. Like you will create your files and all. Okay, and it helps you to develop things faster, because you don't need to take care of error handlings, and also they created, tested everything and deployed then accordingly, and now you have to use it, and you have to build your solution. So you don't need to focus on building the frameworks. But if you notice, big companies like Google or Amazon or the other companies, they have they will build their internal frameworks, so that they can optimize them, they can use them. And what they do at the end, if they wanted to publish it to the global audience or global users, then what they do, simply they publish it, and then it makes it open source, or they makes it proprietary. It depends on them. But there are so many frameworks. That's how got, for example, Facebook released their React. I think it's by library by Facebook. So, and similarly, I think both its Strap is by LinkedIn, if I'm not wrong. And so they have released their frameworks. Like first they are working, they have built their frameworks to perform their team's tasks, and so many frameworks they are internally using, but they are not available to the public. They are not available in the public. So that's how. So maybe Langchain also did the same. I don't know. I'm just assuming. Let's assume they also did it first, and then they released it to the public. Okay, so that's what the so far. I think these are the things that I covered. And was there, okay, one more important thing? I read it so many times, but he taught properly. System prompts, user prompts, and one more thing was there. AI messes. Okay, user messes, system messes, and AI messes. So let's take simple analogy. What he taught, I will tell you in simpler terms. Okay, we already taught in simpler terms. When you are communicating with the LM model, so you say, okay, how I want to do this, I want to this, that, and all. So it's like you user input and user messages. You give it whatever you are providing prompt, that output that you are getting from the model, that is AI message. Okay, now sometimes you notice like you are giving some instruction to the model, like okay, behave polite, behave to do things in a proper way. Then you wanted something to be configured. It's not like you have to respond, but it's like you are instructing it, like okay, you have to be polite with the people and all. So okay, so these are the system prompts. Let's take example of reception. You okay, you applied for a receptionist job, Okay, then you went through a lot of interviews and all. At the end you got a little bit of training about it. Then what they told, okay, now these are the rules and regulations. You have to behave properly, nicely with the customers and all. So these are the system messages that how you have to respond. These are not like you are going to say, okay, you have to behave this like this. Okay, you won't say it to customer. Okay, what you will say, you will keep this in mind when you are talking to the customers. You are when you are entertaining the customers. What we say, entertaining means not entertaining, that means, yeah, when you are entertaining the customers. So okay, so these are the system prompts, like the instruction that has been given to you before generating the outputs, before responding to someone, like you have to consider these things into your mind. So same happens with the LLM models. You are giving some instruction like behave like a, you have to respond nicely, formal, in a formal way, and maybe you have to uh, uh, be little rude to them people, and so accordingly it will change their output and it will respond. So the output that you are getting, that is nothing but the AI message, and whatever that you are providing to it, that is the user message. And if you are giving some instruction that how it behave and how about, that's like you are giving some system message. Okay, so these are the three things. Three, I mean like this. Okay. And now let's jump into the another topic, not topic. Okay, now let me do hands on first. So I'm targeting 30 minutes, so I will cover hands on. So let me recall what I learned yesterday. Actually there are so many things. So first thing, I installed anti-gravity IDE for the first time. I was hearing it for a long time, like anti-gravity. I was watching when Google event over the YouTube, and then I found like, okay, they were talking about anti-gravity, anti-gravity. I said, okay, I will learn it later. But now it's time, it's over. It's a, like I'm gonna grab all the information about AI era, and it's like it's journey, it's a beginning now. Just 12 days, but 12 days are more, and I should focus on building part more. So MCP we have covered so far. We covered MCP, we covered Claude, and now the third step is Langchain. And after that, I will jump into open source models and how to use them, how to build agents. Okay, there are other things as well in the. Oh God, I forgot to activate one voucher. Actually, it's Databricks certification exam. Man, I think I forgot it. Let me do it today. Okay, I mean I will do it when I will do. 1 minute, guys. Databricks voucher. So forgetful. I don't know what happens to me. Forgetful. I'm forgetful or forgetting. Databricks voucher activate. Certifications are there. So many things are, man. Next certification. Okay. God, help me. Maybe this weekend I have to do a little bit more. I'm okay. Forget about it. Let's target 1 hour. And can I create one more timer? I wanted to run one more timer. Not okay. I think I cannot run more than one timer because it is timer. It's not alarm. Okay. So first thing is, oh God. Okay. So first simple thing was like what he does. He created one ID, show open folder. I will say coding, and let's create one more folder that will be Langchain. Okay, so it's my first time experiencing this. Yes, it's very similar to the VS Code. I trust the author, and also for me, it does what it does. It what do we say? Very similar to the. Yeah, they have kept many things similar, but this updated little bit. Like, okay, it's not same as the UC extension icon. I think they copied everything from that so that it won't be difficult for users. Here, Control Shift N. If it is working, no, it's not working, bro. Oh, it's creating new window. Command N. I have forgot it. Let's call it when basics, and And here what we'll do, okay, let's basics. So I will create one. Okay, terminal at least shortcut is working. So first thing is I have to create one UV. Okay, I will name it Langchain basics. I think why I'm keeping it, it's better if I'll keep delete more trash and let me create ls. So UV add, not UV net, it created UV add, and what was that, Langchain. What was it, Langchain, you have Langchain, OpenAI. I believe it was the same. UV sync. Now it will create environment. Just look. Oh, it's already created, bro. So sorry. The logo is looking good. I don't know why, but it's great. Source V. What you are doing? Source V bin activate. Why I'm using Langchain then? If it's I mean not Langchain. I mean why I'm using VS instead of it. I can use VS Code, right? Let's say basics and basics.ipynb code. Select kernel first thing. So initializing virtual environment. It's already installed. Python environments, now it's saying okay, VNV bin Python, yeah. First as usual, hello world. Shift enter, right? Install it, bro. What happened? 3.1.14. Okay, so if you see, it ran, right? But where is the value? It's there. I'm still thinking why I'm using this. VS Code was good. Let's experience it. I like to earlier, a few years back when I was in college. That time I used to install new Windows. Maybe I tried so many times Windows. Every day I was doing this. I experimented with Linux Mint. Still, I like to see the different UI tools and how they are working. I installed so many times Windows, so many times. What we say? Okay, not only Windows, um, Linux, different distros of Linux, and so many things, man. I like those days. Okay, by the way, from Langchain, OpenAI, import chat. I think it was chat OpenAI. Client LLM goes to chat OpenAI. I think it was LLM dot invoke language model input. Something like that you can do. So yeah, so far we covered this one. I don't think here what is there to I think in here no. Oh, I haven't checked man if I'm streaming or not. Otherwise it would be very bad. If I want, guys, if you wanted to, you can subscribe me, please.
Here.
Not net.
What is
It's up to
there
you. Okay, so yeah, let's start Langchain tutorial for beginners. No,
So that anyone can go to chapter 1, 2, 3 within
you
that.
know what? I don't want. If he is gonna use OpenAI for other models, then I will use it. Otherwise, I will
We
continue.
have topics, basics, and all those things. So it will be very handy. Let me just rename it. Let me just say one LLM call. Simple. Now let me create a new notebook. I will say second messages. Messages.ipyme. Perfect. So let me just talk about the message with the help of example between Rahul and Simran. So now let's try to code it. Now Rahul just focus on coding, forget about Simran, and now let's talk to LLM, right? Because see, now let's create a new notebook. This is like very basic notebook because I want to provide this particular masterclass in the form of Rahul and Simran. So now let's try to code it. Now Rahul just focus on coding, forget about Simran, and now let's talk to LLM, right? Because see, now let's create a new notebook. This is like very basic notebook because I want to provide this particular masterclass in the form of structured chapters so that anyone can go to chapter 1, 2, 3. Within that we have topics, basics, and all those things. So it will be very handy. And let me just rename it. Let me just say one LLM call. Simple. Now let me create a new notebook. I will say second messages. Messages.ipyme. Perfect. So let me just talk about the messages. And you know the messages, like why do we need messages, why do we use messages? So now let me just write the code. So in order to use a message, we have like a specific library that we need to install. It's called Langchain core. Langchain core. And by the way, I will be referring to this particular Langchain migration guide as well because they have recently upgraded the Langchain to 1.0 and earlier we were using 0.3, 0.6. They just changed almost all the syntaxes, all the classes. I don't know why. Like, doesn't make any sense. If you want to add something, make new functions in the existing classes, why you need to change the classes names? You like what
they are
get
confused
to break the code bases of the people. Okay, so this is basically the guide. So the thing is, I'm also exploring this particular new, you can say, version of Langchain. This is the older version, not older version. This was the, you can say, traditional way to use those particular classes. Simple. But this is, you can say, latest way to use the classes. It doesn't mean that you cannot use this method. But I'm thinking like, if I'm just teaching you something, so I should just use the, you can say, most recent and latest version. That's it. Okay. So currently I'm not seeing anything for messages.
Okay.
So we can use the messages as is. Okay, makes sense. Okay. Okay, we have a new thing. Langchain.agents. No, this is same. Messages same. Okay, makes sense. Okay, so I'll be just switching between these particular things so that I will just provide the latest code as well. By the way, you can use the older version as well. It is not old. It is just like it is the previous classes that we used to work with. Okay, nothing is there to make you worried. Okay, so let's say messages. So what I will do, I will simply add the library, and I will say uv add, and it will be like Langchain core. Perfect. Langchain core. Did it use Langchain or Langchain core? Langchain. Where are the messages? Okay, Langchain.messages. We use Langchain core. Okay, now we can just use Langchain.messages as well. But yeah, that's fine. Because if it is outdated, we'll see that. Don't worry. So I'll simply say from Langchain code. Oh, we need to select the kernel. Oh. From Langchain code.messages, we will import human message. And do you see all of these code completions? And do you know what? This is not Pylance. This is not something, an extension. This is called anti-gravity's agent mode, which is available for free. If you go to anti-gravity settings, you will see snooze button. This is for AI agent, right? So they are running the free AI models, okay? The pro models for you for free. Because all these code completions are not free. If you use VS Code, you have to purchase it. It is not available for free. Anti-gravity has made it available for free, maybe for shorter period of time, because they have just recently launched anti-gravity. But yeah, for free. Okay. The pro is not something. Oh, we need to select the kernel. Perfect. From Langchain code.messages, we will import human message. And do you see all of these code completions? And do you know what? This is not Pylance. This is not something, an extension. This is called anti-gravity's agent mode, which is available for free. If you go to anti-gravity settings, you will see snooze button. This is for AI agent, right?
Hold on, I wanted to see. I thought in the VS Code also I'm getting, so what's the problem? Why do we need to?
So they are running the free AI models, okay? The pro models for you for free. Because all these code completions are not free. If you use VS Code, you have to purchase it. It is not available for free. Anti-gravity has made it available for free, maybe for shorter period of time, because they have just recently launched anti-gravity. But yeah, if it is for free, you should just take advantage of it. So it will be like human message. and then it will be, let's say, system message, and we want to import AI message. Perfect. And once we have all of these messages, I will start writing my messages. I will say my messages. Simple. My messages will be this. I want to say list. I will say human message. Okay. Human messages, and then I will say content equals, and whatever I want to say. I will say, bro, tell me a fun fact. Simple. But this time, I will not just send this particular message to LLM. I will also set the tone. Remember, system message, and it is saying you are a helpful assistant, right? This is a tone. This is telling LLM that you are a helpful assistant. I will say you are a Gen Z assistant. Yeah, Gen Z assistant, which, or let's say, who always answers in a fun way. Let's say we want to just set the tone for LLM, right? Wow, can you do that? Yes, you can do that. So now what I will do, I will simply say LLM. Oh, we need to import the model as well. This one, remember, we just create the model like this. So I can also create a model first of all. Perfect. So we have the model ready. Now I will simply say LLM dot OpenAI dot invoke. Now I will pass the entire list of messages. System message, human message. Perfect. Now let's see what we get. I will say dot content. So now you will see that this LLM will try to answer in a fun way, in a Gen Z way, which will actually, you can say, impact the response. Obviously, because you are just setting the tone for that LLM. And this way you can ask LLM to behave like anyone. You can even say, hey, behave like, let's say, this person, not like this person, obviously, system should know about this thing. And why it's taking so long connecting to kernel.vm? Yeah, like, see, this is NDK, this is new thing, so there can be so many bugs, so do not need to worry at all. So you can simply rerun it, and you can just cancel it. And you can maybe refresh it. So let me just reopen this anti-gravity. Okay, let's see. Because see, that's why they just provide you these stuff for free in the beginning, so that you can just detect the, you can say, bugs and all. Could not register, service work, blah, blah, blah. Open text editor. Are you serious? Let me just open this open text editor. So I think something is broken in anti-gravity. That's why it is not able to open anything. IP, YMB could not initialize web view and blah, blah, blah. So if it happens with you, you do not need to worry at all. You can simply close everything and just refresh or basically terminate this particular application, anti-gravity, and just start again. It will work after some time because something is broken maybe on the IP kernel side and nothing is broken on in your code. Your code is running fine. And you can also switch to any other code editor, let's say VS Code, which is more stable. But yeah. So I have just restarted my application like completely by ending it or terminating it through the task manager. So now let's try to see. It has detected our kernel this time. Very good. Slow claps. If anti-gravity you are watching this is a bug for you. Fix it. Call your development team. Okay. So now let me just invoke it because you want to see the output.
Alright.
Perfect. Let's wait. And perfect. Now I got the response. Bro, fun fact. Same thing. Bananas are berries, but strawberries aren't. But this time, if you see the tone, it is also using, let's say, emojis or all those things that a Gen Z will say. Make sense? See, wild, right? So this is actually talking like a Gen Z. This is actually talking like a person who is a Gen Z because you have set the tone. That way you can not modify actually, you can direct the responses in a certain direction. Let's say you want to build an LLM who is a kind of comedian, who is a kind of, you can say, write posts about some laughter, or who generates a content about, you can say, around laughter. So you need to set the tone for it. You can simply say you are a comedian who talks about this thing. So you can set the tone. So now you know what? When you just set this tone, whenever you will just invoking this thing with this particular system message, with the system message, it will remember this thing. This is a very basic use case of system message. Okay. Now we have some built-in messages as well. Okay, what is built-in messages? Built-in messages, or I would say prompts, because this is a very basic thing, right? I'm simply writing human message and system message. This is a very standard way. This is like OpenAI style messages. Okay, because system message, human message is only available in OpenAI. If you want to use, let's say, any other model, it will not be like system message or human message, it will be something else. So for solving this problem, Langchain provides us something called as prompts. We have dedicated library for prompts. What does it mean? Basically, let's say I want to pass a prompt, because whatever I'm passing here is a prompt, right? This is a prompt. This is a prompt, right? So we have a dedicated library for prompt. Why? Why? By the way, very good. You can say question like why. So in order to answer your why, let me just ask you a simple question. Okay. And by the way, I have a quick question. We are not importing our API key. How it is able to call it? How it is able to call it? Oh, makes sense, because I think it has automatically loaded everything in our .env. So let me just add that thing as well, because we are not loading all the .env functions, but obviously this is a smart code editor. If you face anything, then you need to import this particular environment variable. Sometimes if the editor is smart, they can automatically import everything in the environment, because that makes sense. It is created in the root directory. But if you want to do it, you can do it like this. From not Langchain, this is not related to Langchain. This is like pure Python, import OS. And then we have a function called load.env. And for that, you need to import one library. It is called, let me open this terminal. This terminal, no terminal has that activated. Oh yeah, this is perfect. So now the library says uv add load.env. Perfect. So this is the particular library, load. I should say load.env. So how we can just say, we will simply say from load or import load.env, and then we simply need to run the function called load.env. What this function does, this function doesn't do anything fancy. What this function will do, it will simply load everything which is saved in this particular .env file. If you have API keys, secrets, variables, everything, it will load that thing into this particular. Usually you should add this. So I'm simply adding it here so that if you see the error, you can simply refer it and you should do that. Let me just run it again, pick the version environment, and that's it. Make sense? So this is loaded. Now in order to set this particular environment variable, you can also write one more command. It says os dot, by the way, there's no need to set it, but I can just show you in order to test it. So I will simply shift this code cell to here. Now I want to make sure that my .env variable is loaded. How I can just make sure? I will simply say if os.environ dot get OpenAI. That means if it exists, print bro API key variable exists. Because obviously I don't want to show you, but this is the confirmation. If you see this message, that means the variable name is created. Okay, and it is taking a lot of time. So as you can see, it says bro API key variable exists. That means this function has loaded and created all of the environment variables. I can also say else value open not found. Perfect. So I hope you understood this concept. This is like very small thing, but it is very important. So again, this function will, let me just write it for you. See, I'm doing so much for you. This function will load all the variables from the .env file, and that means environment variables. Perfect. So it will automatically create environment variables for us for all the variables which are there in the .env file. Perfect. And you should add this code in your all the notebooks. Yes, in all the notebooks. Let me just make it available here. And I know like why we didn't see any kind of error, because we loaded everything in our .env in the root directory. But it is a good thing to do this here. Perfect. Perfect. So now we have added this thing, so we are good. Because I was just looking at the code, I was like, why we didn't create this thing and it's still working? Because thanks to integrating to some things, and bro, there are some bugs, so you need to fix it. So now I was talking about prompts. So let me just write prompts. Ooh. Prompts. So when we just talk about prompts, now basically what are prompts? Prompts are the messages that are sent to the LLM. Simple thing. So that means messages and prompts are same. In a nutshell, yes. So why do we have two different categories, messages and prompts? Messages are like more static way of sending the message to the LLM. Prompts are more dynamic way and more, you can say, user friendly. Let me just show you one thing. So let's say, let me just write it for you. Prompts are more user friendly than messages. Perfect. So now let's say, let me just share the use case. I want to send a message. I want to send a message to what? To LLM. And I want to say LLM dot OpenAI dot invoke. And let me just create my messages first of all. Let me just copy it from here. Perfect. This time I want to say, tell me a fun fact about let's say honey. I want to know the fun fact about honey. Okay, simple. Okay, I will simply say invoke content and I will get the message. System message is not defined. Very good. We need to run this as well. Okay, let me run this. Let me run this. Okay. Okay, perfect. So if I just run this, I will get the message about honey. Okay, makes sense. Makes sense? Okay, very good. Perfect. Bro, fun fact, honey basically never dies. Oh, really? Archaeologists have found jars of honey in ancient Egyptian tombs thousands of years old. That, oh, bro, that was still edible. That's because honey's low water content and high acidity keep bacteria and microbes from growing. Wow. Wow. It takes about 2 million flowers visit. Oh, man. Honey is mysterious. So now we have got the fun fact about honey. Right? And let's say we don't need to set this system message. We are just okay with that. But this is the thing. We want to set the human message dynamically. If let's say you are building something, okay, and you want to get this message from a user, right? So how will you get it? Every time, will you hardcode it? Will you go to the backend and you will change the code? Obviously no, right? So what I can do, I can simply get the input from the user. Okay, I will get the input from the user. Let's say input equals input function, or let's say user input equals to input. What do you want to ask? Simple. I can create this thing. Now user input will be the topic of the fun fact. Now I want to make it dynamic. How I can just make it? Now I will use it something called as prompts. So this is this thing you already know, right? I can just delete this, right? So I will simply say from Langchain core. Now again core, because core is like very important. Core dot prompts import prompt template. We have something called as prompt template. Now what is this prompt template? Prompt template is a kind of special, you can say, module that we have in Langchain core class, which we can build, which we can use to build our prompt dynamically. Really dynamically. Okay. So now what I will do, I will simply say input, dynamic input, let's say. Dynamic input, or let's say dynamic prompt, because everything is prompt. I will say prompt template dot from template. Prompt template dot from template. Okay. Then I need to write the prompt. I will say write a fun fact about. Now I do not know the topic. This is dynamic. Have you ever worked with f strings in Python? It is very similar to that. It is very similar to that. But obviously we do not use f strings directly because people can use the same class for so many other purposes as well. So we simply write a function, or you can write a fun fact about topic. Now this topic will be coming from the user. Make sense? Okay. So simply the dynamic prompt. Okay, and prompt template dot from template, write a fun fact about topic. Now what is the topic? Topic is user input equals input, enter a topic for fun fact. Perfect. Makes sense? So this will bring the topic from the user in the runtime. Okay, this is the dynamic prompt, prompt template dot from template, write a fun fact about topic. Simple. Now I need to inject user input into this thing. User input into topic. Make sense? Okay, user input into topic. Okay, so now what will happen? If I say dynamic prompt, that's it. If I just show you the dynamic prompt, you know what will happen? You know what will happen?
I think it's
If I write dynamic prompt and I simply write this, let me just run it. and it is asking me to put the fun fact, I will simply say, this time, let's say flowers. Okay, hit enter. Now it has created this function automatically. Prompt template, input variable topic, which is the topic variable. Input types, we don't have any kind of type. Partial variables, we don't have any kind of partial variables. And it has injected this particular thing automatically. See, template, write a fun fact about topic. This has injected this variable, but not the value of the topic, but topic variable only. Topic variable only. Now, if we need to inject the value as well, I will simply say dynamic prompt dot invoke, and then you can say dictionary topic is user input. What did I do? I simply invoked it, okay, and I passed a dictionary. Key is topic, which should be exactly same like this, and user input, which is this one. User input is what value I will pass it. Now let's try to run this again. You will see flowers, hit enter. Now see, it has created this prompt for me. Text equals write a fun fact about flowers. Wow. And now we can pass this value to my LLM. I will simply say ready prompt, because this is a ready prompt, which can be used in LLM. I will simply say LLM dot invoke dot content. Perfect. Now let's run this. Okay. I will simply say this time let's say flowers. Okay. Hit enter. Now this time, what will happen step by step? I have just provided a message about flowers, right? It will inject that thing using invoke method, and it will create the ready prompt, which is this one, which doesn't have any kind of variables because it has injected it using invoke. And this ready prompt will go inside the LLM. Simple. And now we have got the fun fact. What looks like a single sunflower or daisy is actually a cluster of hundreds, something thousands of tiny flowers. What? Called florets. I think I read about florets in my 10th standard. I think so. Floret can produce a seed, so a sunflower head is a whole bouquet. Oh, wow. Okay, so now I hope that you have got the context. Like, why do we use template? Now you will say, Ansh Lamba, do you know what? Everything is fine, but that thing is missing. This thing. This thing is missing. This talk nicely and be a little polite. How we can just set the tone? How we can just set the tone for our conversation, bro? This is required, bro. We have to tell someone, like, talk nicely to Rahul. We have to tell it. Okay, if you want to tell LLM, so what you can do? You can use something called as chat prompt template. This is another class. So if you want,
Yeah, it's more about robotic text, not robotic text prompts. What do we call prompt template? I'm writing code so that I will remember what I'm not writing complete code. I'm writing just syntax, like what we have to import, and I'm gonna explore again. So it's not
to
like
set the tone, you will use prompt template, which is very similar to your f strings. If you want to set the tone, the same way you set here in the messages, we have a class as well. What do we? Are you the part of Langchain? No, but yeah, not now. Maybe soon. So yeah, so let's say from Langchain.core.prompts, I will import chat prompt template. This is special. In this, you can just set the tone as well. So I'll simply say, now my prompt will look like this. Prompt template. I will say chat prompt template. Now I will say from messages. Here we say prompt template dot from template. Here we say prompt chat prompt template dot from messages. Because we are creating a messages list, right? Messages. Now this is a list. Now this is very important. Now we do not use system message, human message, AI message, whatever. We simply use a kind of tuple. And we simply say user. User means me. Rahul. User means Rahul. Okay. And it is a request, write a fun fact about topic, right? Now the second thing will be system. This is tone that we're telling Simran, right? System, you are a polite assistant. Simple, perfect, makes sense. So this is the list that we need to create. But here we don't need to write system message, human message, and all those things. No, chat prompt template class will automatically do it for us. Do you want to see? Let me show you. Prompt template. Let me show the ready prompt template. Ready prompt, or let's say ready prompt dot invoke. Let's say we want to write a fun fact about AI. Do you know what it will create for us? What it will create? It will create the same thing like this. But we don't need to do hard work like this. We can simply say generate this prompt for us using chat prompt template. See, chat prompt template value, messages, system message. See, we didn't write system message. We simply write system. And we simply write our message. And it automatically passed or created this particular string. System message content equals to this and blah 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 blah. See, I can even display you the better results. So I will simply say dot messages. See, this is the list. This is the same list we passed here, but this time we have more control because we can just inject the variables in the runtime and we can get the message. Make sense? Okay, makes sense. And obviously here I'm just hardcoding it, but we can just ask the user for it. User input, enter a topic. Perfect. Makes sense? And then we can pass this particular prompt to our LLM, right? I'll simply say ready prompt. Yeah, you can just pass the ready prompt. You do not need to cut down the messages and all. It is fine because this LLM has some good understanding of the context. It can just handle that thing. But if you just want to be pro, you can simply say messages. If you just want to save some tokens, if you're a pro developer, yeah. So let's try to run this. And this time I want to run a topic about, let's say, code editors. Let's say, or let's say Google. Let's say, let's read a fun fact about Google. Google's name is play on the word Google, one followed by 100 zeros, chosen to reflect the founder's mission to organize a huge amount of information. And before that, the search engine was actually called as Backup. Oh, this I didn't know this. The search engine was actually called Backup. Okay. Okay, so this was all about your templates, your messages, whatever you use. Make sense? And I hope that you have clear understanding. Now the good thing is you can create as many variables as you want to in your messages. Make sense?
Because
What do I mean?
we are
Is
passing
let's say
dictionary.
you want to define multiple. Let's say you want to do the system tone as well on your own in the runtime. You are a tone assistant. That means I will set the tone as well. So if I just ask this now, I will simply say user tone, enter a tone, right? So I will simply add this variable as well here. So I can add as many variables as I can. It's not like I can only add one variable while just creating this prompt. So I can just run this now. It will ask me topic. Let's get the fun fact of Microsoft. Okay, tone is, let's say, funny. Let's see what we get. Let's see. Microsoft started in 1975. Microsoft, yes, with hyphen. Oh, okay. And it was founded in Albuquerque, New Mexico, not Seattle. Okay, proof that one of world's biggest tech companies literally grew out of the desert. Oh, wow. And outgrew its punctuation. Yes, this was a fun fact. Okay, so this was all about your chat prompt templates and templates that you use. Make sense? Make sense? Make sense? I hope that you have a clear understanding. Very good. Now we are going to talk about a very, very, very important topic. It's called structured output with LLM. If you are aware of, talk about your chat prompt templates and templates that you use. Make sense? Make sense? Make sense? I hope that you have a clear understanding. Very good. Now we are going to talk about a very, very, very important topic. It's called structured output with LLM. If you are aware of something called as pydantic, then it will be a piece of cake for you. If you are not aware about pydantic, let me just tell you what is that first of all, because if you do not know about pydantic, you are missing very important concept, okay, in Python especially. So let me show you what exactly is pydantic. So let me just open my browser and let me just write pydantic. Basically, pydantic is nothing but a kind of parsing plus data validation library, both parsing plus data validation. See, pydantic validation observability. Let me click this, click on this. Oh, they have changed their UI. Nice. Earlier it was like very pinkish. Now they have just changed it to purplish. Okay, that's cool. That's cool. That's cool. So now, by the way, where's the documentation? Logify Enterprise blog documentations. Okay, Pydantic validation. Yes. Okay, this is perfect. So this is basically their official documentation that you should read. And don't worry, I will also tell you about Pydantic very quickly because you'll be directly using Pydantic with LLMs. Basically, as I said, Pydantic is nothing but and don't worry, I will also tell you about Pydantic very quickly because you'll be directly using Pydantic with LLMs. Basically, as I said, Pydantic is nothing but a kind of library which helps us to validate our data, validate our output, and parse it as well. It is both parsing and validation, both. Okay, so this is a code that we write from Pydantic import base model. Base model is the class that we use or inherit into our class, and then we just create our schema and we can do a lot of things. And you can just read this as well. Like this is the kind of schema that they have created, and they are saying why use Pydantic? Powered by type hints, speed, JSON schema, strict and lax mode, data classes, type text. So if you are familiar with data class as well, if you are, then it is like very very simple for you. Okay, if you are familiar with type text as well, then it is also very familiar with you, familiar for you. If you are not familiar with anything, don't worry, I will just make you explain this. Make you explain what I'm saying, bro. Wait, it's really cold here, so I don't know. So let me just take you to my notepad. So basically, let me just tell you about this thing because this is very important. Pydantic. So now what is Pydantic? What exactly is Pydantic? Pydantic is nothing but a kind of data validation and data parsing library. So let me bring Rahul. So Rahul, let's say Rahul is building a, let's say, function, a normal Python function, right? And that function, okay, that function should have some schema. Schema means key value pairs. Anything, right? Let's say this Python function, it can be like literally anything, but let's say Python function. So let's say he is writing this Python function and he expects the output specifically in the form of schema that he wants. Okay, fixed schema. Fixed schema, or I would say, yeah, fixed schema. Schema is you can say right word. So he wants fixed schema. Make sense? Okay. Now we know that whenever we create our own Python functions, okay, we define return, what we want to return. But let's say you are using LLM. Okay, you are using LLM to do that work. Now LLM is what? LLM is LLM. LLM can generate the output in that particular specific format, and sometimes it will not. Sometimes it will not. So in order to direct LLM, hey LLM, listen to me. Hey Simran, listen. You need to reply with this schema. You need to say key this, value this. For example, if I bring my anti-gravity here, so if you observe, what is that particular key it is using? Nothing. Literally nothing. Right? So let's say I will say user message is this one. Write a fun fact about topic. Return the result with return the result in key value pair in a JSON, or let's say in a key value pair with key equals to response, with key as fact and value as fun fact. Perfect. Let's say I'm directing LLM. I'm providing some information to this LLM. Okay, let's try to run this. Let's see what happens. And the topic, let's say honey. Tone, let's say funny. And let's try to run this. Perfect. Now, can you see the difference? Now I have got the response with fact as my key and value is the response. So what I did, I directed LLM to generate the response with specific key and value pair. What is the benefit of it? Let's say my downstream. Now you say what is the advantage of it? Let's say the downstream of this particular function is using that key. Makes sense? Like maybe they are dependent on this thing. We have another Python functions. Okay, dependent on this. So we have dependency. Cool. So that means we need to make sure that this Python function basically actually LLM. Okay, because we are using LLM. So this LLM will generate the fixed schema, and it should not generate something on its own. Simple. This is our goal. This is our end goal. This is Rahul's end goal. Makes sense? Fixed schema dependent on downstream functions. It can be anything. It can be anything. We do not know. Maybe data scientists are using it. Maybe data analysts are using it. Maybe someone else is using it. We need to make sure our schema is intact every time. So one way of doing that is, you have already seen, directing LLM in the prompt. But obviously, we cannot direct it in the prompt like we can, as you have seen that it is successful here, right? Let me just write it for you. Let me just remove it from here. Let's create a new notebook so that you will have a better understanding. Let's create 3 structured output dot itymp, and this is my code. Or let's create markdown. First of all, we'll look at prompts. Basically, writing in prompts. Writing in prompts. Makes sense? This is like one way of doing it because we have so many ways. One is writing in prompts, and what is the way to do that? First of all, we need to load this thing here. Okay. Attach this in our variable. Then we can load this entire thing, right? Perfect. And I can attach it to this one. Okay, makes sense. And I can remove this thing because I don't want to apply this thing. And I will simply say topic. Simple. Or let's say honey. Makes sense? Okay. Or I can even remove this thing because now we're focusing on LLM, so I do not want you to be confused on prompts and all. Okay, so I'll simply say LLM OpenAI dot invoke. Tell me a joke. Let's say, tell me a joke. Perfect. So we have this. Let me just try to run this. Langchain core. Okay. LLM OpenAI is not defined. Okay. We didn't define the model. Really? Okay, we didn't define it. Not a big deal. This is the model. Okay. Tell me a joke. Now I will guide this LLM model, okay, to generate the output in a specific, you can say, schema. Makes sense. I will say, tell me a joke. Generate the output in key value pair format with the following keys: setup and punchline. Makes sense? So it will be having 2 keys, setup and punchline. Okay, let's try to see the answer. It should return a dictionary, and let me just say result, and then I can say result dot content. Let me just run it. Okay, so I have setup and I have punchline. See, so it has actually generated the output in the key value pairs. That is me, and I loved it. Setup. Why did Scarecrow win an award? Because he was outstanding in his field. Okay, wow, nice job, very nice job. 10 out of 10. 10. Okay, now one thing is clear that we can guide LLM in the prompt, but it is very simple when we have like a very simple prompt. Tell me a joke. Tell me this thing. Tell me that. But when we have, let's say, a very detailed prompt, a very big prompt, dynamic prompts, when we are just running complex workflows, we cannot guide the LLM to generate the output in a specific format, right? Then we have to follow a structured approach. That structured approach is called Pydantic. Let's try to discuss that. And you will understand Pydantic only even if you do not have any knowledge with that. I will just make you understand it. Structured output using, let's say, Pydantic. Using Pydantic models. Now, what is Pydantic model? Okay, and you will also see the difference between Pydantic and Pydantic. Just stay with me. Now, using Pydantic model. So now we need to make sure that we are guiding LLM in a more formal manner to generate the output in a specific structure, right? So we use a library called Pydantic import base model. Now, what is this base model? Base model is a class that we use to create our schema, right? And how do we create our schema? We simply create a class, and I can say, let's say, LLM schema. Simple. And I will inherit this base model in my normal class. Simple. Now within that, I need to define the key value pairs. Not key value, basically the schema. Like all the columns that I need, all the keys that I need, everything. I need just 2 things. One is, let's say, what was the schema here? Let's use the same one, setup. So that you can relate better. Setup, right? And what is the data type I want? Oh, that means we can even control the data type of this thing as well. Exactly. I will say string. I want my setup key is of string type. Then I will define punchline. And this will also be of string type. Makes sense? Very good. Now this is my class. Let's just run this model. That's it. So this class is created. Do you know what? Okay. Now, if let's say I want to use this particular LLM, basically use this class, use this schema, I cannot use any other thing. What do I mean? Let's say I want to create a class. So I will simply say object equals LLM schema, right? And I want to just create an object of this Pydantic. So I'll simply pass a dictionary. I will simply say, let's say setup, right? Setup will be setup, and punchline will be, let's say, punchline. Punchline will be, let's say, punchline. Or let's say some setup, right? And punchline will be, let's say, some punchline. Okay, perfect. And now let's unpack this list like this dictionary, and let me just try to show you the output. OBJ. So what did I get? I got this Pydantic object. If I want to now use this object, I will be using like this. OBJ dot, let's say, setup. I want to use a setup key within this. I will write like this. I will get this, some setup. Got it? What is the advantage of it? I told you that this is a kind of data validation library. If I pass some wrong thing, let's say I do not pass setup, I pass, let's say, ketchup. Wow, what playing number? No, nothing else. So let's say ketchup, some setup. Now if I try to create this object, it will throw the error. Why? Validation error. It will say, bro, you cannot do this. You cannot do this because I can only accept not either, basically both. I can accept setup and punchline. If you will not provide me this thing, I will not allow you to create an object. Wow. That means if LLM generates an output and LLM does not follow our schema, it will not allow LLM to generate the output, and it will protect us to just deliver that pseudo schema or let's say broken schema to our downstream workflows. This is an amazing thing. This is a kind of data validation check. Very good. Anshulamba, does it only check on the keys or it does something else as well? It does this data check as well. For example, let's say I pass some integer value here by mistake, 1, 2, 3, then also it will fail. See, validation error again, because I'm expecting of string type. So this is called validation. Okay, so data validation is done. Now what about data parsing? So this step is called data parsing. When you are parsing the values and it is creating this identity object. Let me just correct it. If I say sum setup. So what I did, I simply passed this particular class and I parsed my arguments. Setup, sum setup, punchline means sum punchline. Makes sense? And then only I got my object. Wow. This is literally wow. And you know what? Now let me just show you with LLM. So I will simply say LLM structured output because I'm creating a new LLM object, right? I will simply say my normal LLM, which was OpenAI, and then I will say with structured output. And now I need to pass the schema. And what is the schema? This is a schema. LLM schema, right? Pass this. LLM schema. Perfect. Now if you use this model, now if you use this model, this one, this will generate every time the output in this particular structure, and I will not even tell LLM that generate the final output in this structure. This is the power of it. One pro tip, that whenever you are defining your class, you should always define a kind of description. Why? Because LLM is not magic. LLM will use your information as context. Now just tell me one thing. If you are a human, if I will say you need to create a joke, okay, and I know you are a great comedian, you will just create it like this. So let's say you create the joke, and I say you need to generate the output in these two key value pairs. Do you know like what should be the setup and what should go in the punchline? Obviously no, right? So I will tell that what should be go in the setup. I will simply say field that I need to first of all import. Perfect. And then I will write field description, setup for the joke and joke. Setup for the joke and then punchline for the joke. Make sense? So these are descriptions. These are very important because LLMs are all about context. Simple. More and precise context you will provide, better applications you will be able to build. Simple formula. So this thing is done, and let's try to test it. If it is working fine, I will simply say, tell me a joke. That's it. I will not tell LLM to generate the output in any structure. I will simply say generate a joke. Let's see what it generates. I will simply say dot content. Let's see. Okay, LLM schema object has no attribute content. Makes sense. So I can remove this content. Makes sense because that is a identity object. That is a silly mistake. Perfect. Now what I got the response in the form of LLM schema, which is this class. Then setup. One key, its value. One key, its value. Perfect. This is not just a generic string. This is not just a generic string. This is a identity class object. I can even show you. If I say result, and if I say type of result, let's see what we get. See, this is an LLM schema object. If I want to use any key value pair, now I can use it easily because now I'm sure that LLM will generate the output with those keys. I will simply say result dot.
Let's say punchline right now. Let's see. Oh man, today I'm gonna
perfect
sleep.
That's how you guide LLM to make better AI agents. Because remember our discussion. Our main agenda is to build this kind of workflow. So let's say this output of this node.
What the heck? Output
of this node is actually like this. This node is dependent on this one, right? This is the upstream for it. So if it generates something else, this whole workflow will be broken. So we need to make sure that we pass the exact schema that we should pass. We should not tell everything. LLM please generate this. LLM please generate that. Build LLM objects smartly. This is the concept of Pydantic.
I got it.
If you are learning Pydantic for the first time, take some time to digest this information because this is new. If you already know Pydantic, then it will be like piece of cake for you. You are simply implementing its, you can say, feature. That's it. Make sense? I hope like it was easy. Now let's talk about the third type, which is not very recommended, but people still use it. Let me just tell you what's that. It is called as type-dict. Okay. Using type-dict. Perfect. Now what is type-dict? Type-dict is exactly same as Pydantic. Okay, exactly same. Then why are we using two things? Okay, let me tell you. So this is exactly same as Pydantic. But Pydantic is like the principal of the school. Okay. And type-dict is like the class teacher. Wow, Anshulamba. Just saw this puzzle that you have just created. Okay.
Great.
Principals are like very, very strict, right? They will not listen to you. They will simply do this. Like in my school, like I got this. So they will not listen to you. They will not listen to you that why did you make any mistake? If you made the mistake, tar. So they're like this. Class teachers, on the other hand, if they are good, they'll listen to a mistake. Even if you make a mistake, they will simply say, okay, do not do it next time. Exactly same thing happens here in Pydantic models and type-dict. So you define the schema for sure. Let me just show you. So I will import the type-dict from typing. From typing, import type-dict. Okay. And here I will create a class same way I have created there. Class, let's say LLM schema TD. That means type-dict. And I will add type-dict class. Same way. Everything is same. And again, same things, name, age, or not name, age. Let's say setup, string, and punchline string. Same. Right? See, exactly same. Now, if I just show you, let's create this object. Okay. Now what will happen? If I just create an object of this, object equals LLM schema TD and LLM schema TD, and if I pass a dictionary with same thing, setup, let's say some setup. Why is again writing tier down? Let's say punchline, and let's say some punchline. Perfect. Let's say some setup. If I do this, what I will get? I will get dictionary, not an object. Dictionary, simple dictionary. Okay. If I want to use any object, I can use it like this. setup, or I can use dot get option. So simple dictionary. This is not an object. Simple dictionary. Okay. And you know what is the advantage? Why I just said like it corrects your mistake. Let's say you wrote it here ketchup. What happened in Pydantic? It failed, right? Let me show you. It won't fail. It will simply say ketchup. What? What? That means you made a mistake. You wrote ketchup, but still it will not fail. Why? It will create the output using your mistake, and it will simply give you the error on the typing part. Basically, these are called type hinting. Type hinting. So when you're, let's say, typing something wrong, you will get the error while typing it. It is not runtime error. It will not fail your code. Okay. So this is like class teacher. She will say, okay, do not make a mistake next time. But if you made a mistake in front of your principal, he will say, come here, bro, come here. Come to my office. And I used to just get those announcements. Like I was in, I think, class 8 or 9 or 10. And we had a mic. We had like cameras in all our classes. Okay. And if someone is like doing something crazy in the classroom, a principal used to watch everything in the cameras. And if you made a mistake, bro, you're gone. So on, I would say every week, there was an announcement used to happen in our whole auditorium, whole floor, I would say. Ansh Lamba, come to the principal office. I was like, oh, bro. So yeah, crazy stuff. But I used to go to the principal office with all of my friends. I never went to the principal office alone. Alone. Because whenever I go there, like whenever I used to go there, I simply take names. I used to take names. See, I was not alone. I was with this. And then all of those people would also come down to the principal office and then let's have a group discussion together. Okay. Crazy stuff. So now I was saying that we can create this object like this. Simple. Now we'll say, then what is the benefit of it? There's a benefit. We can still use this particular class to provide the context. Because we simply need to provide the context to LLM. Right?
What are you doing?
We simply need to provide the context. I can simply say LLM structured, or let's say type it, right? And I'll simply say LLM OpenAI dot with structure output. Perfect. And this is my LLM schema TD. Now if I ask the same question here, this thing, I will get it. I will simply say result. Perfect. LLM OP. What is LLM OP? What is LLM? Oh, OpenAI. I think we just need to use type it. Perfect. So here you will see that you will still get the answer in the form of dictionary, but not in the form of identical object. Not in the form of identical object. Wow, very good. Makes sense? Makes sense? Very, very, very good. But what is the advantage? If let's say your workflows are not very, very error prone and you are not very much dependent on the same keys, then you can simply use type for just as a context. But when your workflows are very, very strict and you do not want them to create any random key on its own, you can use Pydantic. So it's totally depends upon the Pydantic. And you know what's my philosophy? If you're using a specific schema, right, and if you want to just use a specific, you can say guide to your LLM, just go with Pydantic. Go with Pydantic for the final output. And if you just want to provide some context to your LLM, then simply go with Pydantic. Simple. I hope it makes sense. Like when should we use Pydantic and when should we use your type? Make sense? Okay. Okay. So now let's try to cover this important topic. And I would say this is one of the most important topics. What is this topic? Chains. And obviously we are learning Langchain. So as you would have already guessed that this is really important. Chains. Basically what are chains, or basically what is a chain in Langchain? If you're a data engineer, you can better relate this concept with your something called as pipeline. So being a data engineer, chains are very similar to the pipelines. And what are pipelines? Pipelines are nothing but sequence of tasks. If you would just define it in one line, sequence of tasks. So let's say this is Rahul. Rahul will become so popular now. So let's say this is a data engineer, okay? And now this data engineer needs to build the entire pipeline. So how this pipeline look like? Let's say this is the task number 1, maybe, and task number 2, maybe like this, maybe like this, maybe like this, like very simple pipeline, right? And if you're a data engineer, you would know like how to build this. So let's say this is 1, this is 2, and then this, then this, very simple pipeline, right? Basic pipeline. So now what we need to do, being a data engineer, let me first remove this. So now let's say this, you have this pipeline. In data engineering language, we just call it as a pipeline. And in AI engineering language, or basically in Langchain language, we just call it as a chain. Okay. Chain. Remember one thing, this is my personal tip. When we just create pipelines, we create small pipelines, right? Listen to me carefully. So let's say this is only one pipeline. And this is a very simple, straightforward pipeline. And if we want to create complex pipeline, what do we create? We create dedicated nodes. So let me just make you understand this concept with our previous example. So let's say we have this particular Langchain, right? So now I'm talking about only this part. See? So let's say you want to build something like this. What is this thing? This is a pipeline, but smaller pipeline. Perfect. What is this? Pipeline in itself, smaller pipeline. What is this? Smaller pipeline. And when we combine all of these things, this become our parent pipeline, or basically the workflow. Make sense? So what we are learning currently, we are learning about chains. So chains can be complex, but if you want to become, you can say efficient developer with Langchain, do not create long and complex chains. Always create smaller chains, and then you can combine those chains. Are you getting the point? So let's say one chain like this. Okay. One chain like this. You can just create only one node for this chain. chain, only one, and then you can just connect, or let's say you have, let's say, similar chain like this here, you can connect it. Make sense? So instead of creating the whole thing in one go, you can just have this one chain first of all, second chain, then you can just connect both the things. Do not make everything available within single chain. It will be very hard to debug. This is my personal recommendation. It's not like hard and set rule that you have to break down the chains or you cannot build long chains. These are like best practices. Again, the choice is yours. If you're a developer, you can just do whatever you want. But this is the concept of chain. Make sense? So this sequence of tasks is basically a chain. Makes sense? Very, very good. Now you will say, Anshnava, like in data engineering world, we just use maybe Airflow to build the chain, basically to build the pipeline. We also use Azure Data Factory. We also have, let's say, AWS Glue and all those things. What do we use in Langchain? Because we have just covered how we can just make wrappers on top of our agents, prompts, and everything. The good answer is, or you can say the good point is, we can just use everything within the Langchain itself. You don't need to combine it with that third-party tool or whatever. We have like inbuilt functions available. Let me show you. Let me just create a new folder. Let's call it as chapter 2. And let's create our first notebook. And I'll simply say basic chain or basically first chain. First chain.icynb. Okay, perfect. Now I've already talked about what are chains. Chains in Langchain. Okay. So now let me first of all import that boilerplate code. So this is the code. Let me just bring it here. Perfect. And let me just select the markdown, this kernel, and make it as Python. Perfect. Let me run this. So this is our boilerplate code that we have just copied. Let's wait if our LLM OpenAI is created. Because see, this anti-gravity is really new, and I've been using for I think almost a month now. I started like using this last year, and I personally feel like it's a great tool. Obviously, it is free. Second thing is, it has like so many bugs. Like sometimes it takes so long to just run some cells, and we have to just close it and open it again. So there are some bugs, and that's why they have just kept it for free. I don't know. You can see now it is also taking so much of time. Like it should not take much time. If I would be just running this in my VS Code editor, it would be like this. VS Code is like very stable and very good. So yeah, let me just close it and open it once again. Let's see. So I have closed the anti-gravity and I have just ran this again, and now it is done. Sometimes it takes like this much of effort. Okay, so our LLM OpenAI instance is created. That means we can now just call the models. Now let me just show you a basic, you can say, chain that we'll be creating, and this chain is very cool. So now you know that how do we connect with LLM, and how should we connect with LLM? We should always create a prompt first of all, right? Obviously. So we will be creating a prompt. So let me just write first chain, right? So in this first chain, I will first of all create the prompt. And how do we create the prompt? You should know now. You should know now. You should know by now. So now I will simply say prompt template, because first of all we create a template, right? Prompt template equals chat prompt template, and let me just import it if it is not imported. No, it is not imported, so let me just import it. From Langchain core.prompts, import chat prompt template. Okay, perfect. So we have chat prompt template.from messages, and system message URL helpful assistant, simple, and human is input, because we do not know like what will be the input. Okay, and we import chat prompt template. Okay, perfect. So we have chat prompt template.from messages, and system message URL helpful assistant, simple, and human is input, because we do not know like what will be the input. Okay, and we are creating a, you can say, chain which can take any value, like basically anything. It is not just a, you can say, joke generator or fun fact generator. It can take anything. So that is why I'm not guiding anything in the human message. I'm simply saying input. Sorted? Good. Now this is my first task. Okay, let me just write it task 1. Task 1 prompt. I want to create task 2. Let me just first of all run this. Then I will say task 2, and this task 2 will be LLM, right? Because I want to send this message to the LLM. So I'll simply say LLM OpenAI. Okay, let's actually automate this as well. So we already have LLM OpenAI here. So I'll simply repeat this step. That's it. Perfect. So this is our LLM. Third step will be, I want to use a parser. Now, what is parser? If you remember, if my previous notebook, if you will see that every time I use something called as content, if I want to fetch only the content value, see, dot content, dot content, dot content. Like every time we see dot content, because if we do not write dot content, we will get the unnecessary things as well, such as parameters, those things, let's say token size and all, and we do not need to show that thing, right? So one option is we can create, like we can use dot content, right? Or we can use a built-in function in Langchain, which is called Spring Output Parser. So what that output parser will do, it will take your generated response, and it will only fetch the content out of it. And behind the scenes, it is doing the same thing. It is writing dot content, but it is automating that thing, and you will not need to write again. So I can simply say from Langchain dot, I think, parsers. Let me just check here. What did we use? Output parser. Let me just check the class for it. Let's try using what's this? Dot parsers import Spring output parser. Yeah, let's try this. No, let me just check the library for this. String output parser. This is our Langchain. String output parser Langchain. What is the library, bro? What is the library? Yeah, it's called Langchain core dot output parser. Okay, makes sense. Output parsers. Okay. Perfect. Yeah. So we have a function called output parser, right? See, like this. Now I can just use this. How? Let me show you. Task 3, string parser. So I will create an instance of this function. I will simply say string parser equals string output parser. Simple. So how many tasks have I created? 3. Perfect. If I will be just manually running all these tasks, I know how to run this. First of all, I will invoke this template. by feeding the value inside this. Then I will pass this prompt template into this LLM OpenAI. Let me show you. So first of all, let me just say manual. Manual thing, force chain. Let me just write it for you. Manual invocation. So manual invocation will look like this. So first of all, I will simply say prompt template. So I will say template equals prompt template dot invoke some value. Let's say, and what is the key? Input. Okay. What is the capital of France? Then I will say LLM dot invoke template, and then I will say final output is final result equals this dot. Let me just put it in the result, and then I will say result dot content. Right. This will be a manual invocation of every single step. Just imagine that you want to run this particular chain and you are just manually invoking every step. That's how you build data pipelines? No. So how you can just create it? So I'll simply comment it out because we are not manually running it. If you want to just run it, you can, but I am not running this at all. Okay. So I will say chain invocation. So I can invoke it through the chain. And in order to invoke this in the form of chain, I will be creating a chain, obviously. So I will simply say chain equals whatever value you want to use. And there are basically two ways to create the chains. I personally like the first one. So what do we need to write in this particular method? You simply need to use a pipe operator, which is also called as LCEL, Langchain expression language. So what do I need to write? I just need to display or basically write the function in the order I want to run it. So first of all, I want to run prompt, right? Prompt template. Then I will use pipe operator. Then I will simply say LLM OpenAI, my second function, task basically. Then this, then pipe operator. Then I will simply say string output parser, basically string parser. Perfect. String parser. Perfect. So this is my chain now. And you know what? I just need to say chain.invoke, and I can pass the dictionary input. Let's say what is the capital of France, whatever I want to ask. Okay. So now do you know what will happen? It will first of all invoke this thing, first function. Then it will invoke LLM OpenAI, and then it will invoke string parser automatically. Let me show you the result. Let me just run this. See, you are just getting the final answer automatically. You didn't run this manually, you didn't run this manually, you are simply getting the final response as is. The capital of France is Paris. Really? Yeah. Okay, makes sense. Now, you will have so many questions in your mind right now. I'm so sure because I also had so many questions when I was learning about Langchain. How this flow is working, how input is going, how the data is flowing. I know. Wait, I will just explain you everything. So how everything is going on. So let me just open my this thing. So let me show you how the things are happening. So first of all, we have, let's say, 3 tasks, right? So first of all, we have template, right? First of all, we have template. Then we have LLM OpenAI. Let's say LLM, just LLM. Okay. Then we have string output parser. Perfect. So we have this chain, simple sorted. And you know what will happen? First of all, Rahul will send the input. Now input can be anything, right? So input will go like this. Input, and he asked, what is the capital of France? Just focus on because this is very important. And this will cover your all the fundamentals. And Rahul, so sorry, I'm just removing your name because I want to just put the input. Perfect. So this will go here as the input. Simple. Now this template will receive this as input. Okay. Let me just write it here, input. So this is the input. Okay. Let me just change the color as well. Let's say red. Okay, perfect. So this is the input. Okay. What is the capital of France? Because this requires the dictionary. If you just look at the template, how do we invoke it? We invoke it like this, right? Like this. Perfect. Now we will generate what? How our output will look like. Output will have obviously the template object. Human essay system message. Remember? We discussed it in the fundamentals here. In the messages, like how we just use the templates. Remember? Like this. So now, I think we discussed here as well, like how do we just create the prompts here. See, when we invoke it, what do we see? So now what will happen? This will generate the AI message, human message, something like that. Simple. Let's say it generated. Let me just invoke it. We'll say like, bro, we forgot, blah, blah, blah. So let me just run this particular thing. And perfect. This ran fine. And let me just run this. And let me just run this prompt thing. And I will not invoke this function. I will simply show you what ready prompt look like. Ready prompt content is very important. Now let's say, what is the capital of France? Now let me show you the ready prompt. What is the capital of France? Okay, this is the thing. This is the ready prompt. Right? And if you are using, let's say, chat message, let's say chat prompt template, then obviously the message will look like something else. Like if you are using chat prompt template, like here, if I just invoke this as well, just for you, I can show you ready prompt. And let me just comment it out here as well. Topic, let's say honey, and tone, let's say funny. So this is the value that I will see. See, chat prompt value, message is equal to this, and whatever values do we have here. Perfect. So I'll be having values like this. Make sense? So this will be my output. Yes, this will be my output, and obviously it is too big, but yeah, this will be my output. Make sense? Now I have this output, this output will actually flow from here and it will go to here as input. Okay, it will go here to as input, or I can also move it here so that you can understand it better. So this will be my input and this will go here. this will be my input. So output of one task will exactly be the input. Why it is so important? Why I'm stressing so much here? Because the next topics are strongly dependent on this concept. So this output will become my input, whatever it is. We cannot tweak it because it is automated. Whatever it will generate, we have to accept it. V means LLM node. Makes sense? Now this LLM, what it will generate its own content like AI message and quarks and whatever, and this will become its output. This output will become now input of string input parser, basically function. Make sense? This will become its input. Now this parser will generate what? Only content, because it will simply say dot content and whatever. We already know like what it will do. So this is the basically the flow of it. Like how does it work? Make sense? So I have just rearranged this with the value so that you can better relate with it whenever you will be referring to this particular nodes. So I hope now you know what is the intent. The intent is you need to be very sure while creating the chains, because the output of one node, basically task, will be the input for the next node, or basically task. If you are expecting here something else and your previous task is generating something else, then it will not work, because it will simply mess up with the you can say requirements. Because let's say you are here requesting a kind of different input variable and you are giving it something else, so it can actually break it. So this was a very simple example. That's why it worked extremely fine and we didn't need to make any changes. And by the way, we were just talking about we have like 2 different ways to run it. Yes, so we can also run it with the help of runnable sequence. Now what is this runnable sequence? This is basically the kind of function that we can use in order to create the chains and basically run it. I personally like this pipe operator, but if you want to know, I can just show you as well. So we'll simply say optional from Langchain core dot runnables, I guess, import runnable sequence. So you can simply say chain 2, or let's say chain 1 equals runnable sequence, and in this particular list, we just need to pass all of the functions. All of the functions. Functions means like all of the tasks that we have created. Make sense? Make sense? Make sense? Okay. So now I can simply pass like runnable sequence, and let me just say prompt index, and then LLM, OpenAI, and then we have output parser. Perfect. So we can also write like this. LLM OpenAI is not defined. Oh. LLM OpenAI. Output parser. Very good, very good. Very good. Code awareness, whatever model this integrator is using. So see, we also got this value, but I'm a big fan of using this because it makes the chain more readable. We can easily define that you can say dependencies, and it is very much similar to defining dependencies in Airflow. We use like this operator in Airflow, tuck, and here we are using pipe operator. It's fine. So yeah, choice is yours if you want to use this one, because some people don't like this one. So I'm not restricting you to just use one method, but you have the options available. Okay, perfect. So this was a very basic example of chains. Now in real life, we build chains which require some custom functions as well. What do I mean by custom functions? So basically, let's say you want to build a chain where you want.
I want to stop it now. It's been cancel. No, because it's what is time? Oh fuck, 5 o'clock. People will start waking up in my home. I'll will start. Yeah, most of them will woke up now. Oh, what I'm saying, most of them will wake up at this time, and I'm gonna. I don't know, man. Very bad. My sleeping time became disastrous. Oh, no problem. Thanks. Bye bye.